This one just come out of the oven. A little dirty. I took it out in the garage with a wire brush and cleaned up the little stringies off of it. A little stringing. Look at the geometry. Beautiful. Like something you'd buy out of a store, huh? Nearly. Get the little chamfers in it. Good bed adhesion. Look at the adhesion. Stuck very good to the bed. Corners. Try machining that out. Look at the geometry. Nice. It's gonna fit nice. The only one in the whole entire world sitting right here. Did a good job, Aaron. So I've been at this print for 23 hours and 52 minutes. There's 2 hours left. It's a flagpole holder. It was on the outside of a house. I'm printing with PETG filament. Got it at Kodak. It's first time printing with it. And printing on an It's Max printer. Got it off Amazon. You can see some layer lines in it. Overall, looks very good. I know on the camera, this is a 4K camera, so you can see it kind of brings out any little imperfection or flaw. But in person, looking at this with the naked eye, a lot of that you're seeing can be wiped off. Not the layer lines, but in person they're not as apparent. And I believe that with a little sandpaper they can be smoothed out. I want to take the cap off. Go down inside. Let's take a look. It's a fairly large print. It doesn't look as big on camera as it is, but at the end of the video you'll see that it's scale. I'm very impressed. You know, I used to have a different mindset with 3D printing. I just bought this 3D printer. This is like the 5th or 6th thing that I printed on it, and I've got to say that I love it. Now when I bought this thing, it was quite a bit of money for me anyways. We're talking tax and all in the ballpark of $1,500. That's not something that most people would want to spend on something like this. But if you're looking for something that's industrial, I mean, this is really nice, and I would say it's the way to go. This is like my 4th 3D printer, and so far this is my favorite. It's got, you can see how long it's left. It's a touch screen. It shows you the model, and it doesn't. This model doesn't really have a lot of graphics on it. It might have been something that I clicked on, but normally it would show the color and also show a more detailed graphic image there. But you can go here, turn the light on and off, whatnot. Down here, I've got it set that when the print is done, it's going to power off, because I didn't know where I was going to be. But I plan on being home for the next hour or two, so it gives you your bed temperature and stuff like that. PETG filament. This is the first time I've printed with it. It's a lot different than what I'm used to. What I'm used to is PLA, and it's just a filament that you never really have trouble with. You know, I've never really had an issue with PLA. I can show you some things that I've printed on it. Little carabiners and pin holders. even a base. This was one of my first prints inside of this printer. That base. But I do this on the side for fun. It's a hobby. So if you're interested in getting something 3D printed, or maybe even design, as in CAD modeling, I do that, and I do offer it. So just hit me up in the comments, and I'll try to get back with you and we can work something out. And I do NDAs, if you know what that is, and I offer that. So this is a really neat printer. It's got a removable build plate. It's magnetic. You just flip it up, crack it in half, and the print pops right off. It can be Wi-Fi driven, or I just use the USB. It's got an auto leveling feature. It's kind of like a assisted, kind of helps you out. It just levels right in the center. You just take your shim, stick it in the center, and take it down until you can feel it. Just grab it. Here's my extra build plate. It comes with an extra one. And the other side, you can do like different abrasive materials, such as carbon fiber and stuff like that. More exotic filaments. But overall, it's a wonderful printer. If I had it my way, I'd have about 10 more of these, and I would actually be making money on them. And maybe one day, I hope, that is my goal. So like I said, if you need something designed or printed, let me know. I also can print things, make castings of it, and then I would say mass produce it on a consumer level. You know, if you need 100 parts or whatever, you know, something like this wouldn't be ideal. You know, if somebody needed bulk order, you know, maybe 10 of these, or maybe 50. You know, I probably wouldn't, if I'm cutting it or printing it out of PETG, but seeing that it's taken over 2 days to print, I probably would not want to 3D print every single one of those. So what I would do is go get a casting kit and reverse mold it. So I'd print this part and mold it into a silicone mold, and then I could pour the other stuff and make parts. So I have done it with 3D printed bolts, nuts and bolts, and it came out very well, very easy to do. And I wouldn't say there's profit in that, because I never pursued it. I just did it for experimentation, just to see if I could do it, and I was able to do it, and it was fun. Very easy. It was an easy learning experience. So if you have any questions or anything about this printer or about 3D printing, or need some help, just let me know. Leave a comment. If I can't answer it, maybe somebody else can later in the future. Maybe one day this video might get a little popular. But if not, just hit me up. I'll try to see what I can do for you. Thank you. I've been 3D printing for several years now. Like I said earlier, you know, I've had several 3D printers. I've come a long ways, and it's been quite a learning curve. I use Fusion 360 to model with as an at-home hobbyist, and I use it for, I have a Shapeoko CNC router also, and I use Fusion 360 to program it, and that's a lot of fun. I have some videos out there on my channel that show how to assemble one if you do purchase it, the XXL, and also some of the things that I've designed and made on it. So this printer, you know, like I said earlier, I learned a lot on this particular part. What I've learned on this one is, you know, before I had a mindset, and what I've learned is the reality of 3D printing. So the reality of 3D printing is, with this grade of printer, you know, that size of a part there, we're talking several inches long and tall, and odd extrusions coming out of it. It's a flagpole holder. It mounts on the side of a house and a flag sticks in it. So what I've learned about it is, yes, it's very time consuming. Very time consuming. That can be frustrating. But like I said earlier, you know, if you were going to mass produce this, you would not, on a small scale, you would not, you probably wouldn't use this method. You know, you could use it to prototype it, get what you wanted, and then cast them. You know, that would be ideal on a larger scale. And that's what I learned with this. You know, a lot of people think, you know, it's going to take 2 days to print that. That's not worth it. But, and honestly, from what I've seen and from over the years of being in this trade, you know, I've come to the realization that it is worth it, and it is a very neat thing that this thing is capable of doing. These things are able to produce parts that, you know, would be difficult even in the machining industry. You would have to have a multi-axis CNC machine that was capable of milling or turning specific parts of this, and it may not be able to be done in one part, depending on the machine that you had. If you had a 5-axis, you could definitely do it. It may take multiple operations, but you could possibly do it. But there is some geometry on this part, internal geometry, that, you know, I don't know if we could really pull. You know, there's no radiuses or chamfers on the inside of this part. You know, in traditional tooling, you would run into the problem that you would need edge relief for the cutter on the tool. Well, 3D printing, with 3D printing, you don't necessarily need that. This thing is capable of printing in ways that CNC cutting machines are not capable of even cutting. So I'm just very impressed with this, and I wanted to share with you guys my thoughts and things that I've learned on it, in hopes that it will further teach anyone else out there that's wanting to learn this stuff. I learned a lot with Fusion 360 through Lars Christening. He's a very super sharp guy, and I suggest anyone that's wanting to learn how to model, CAD model, and you're able to have some kind of computer access to a computer, look up Lars Christening and download Fusion 360 and start practicing. And it's awesome because there's a lot of things out here like this. For instance, the reason why I'm printing it is because this part does not exist in the world. This is the first time that this part has ever been made in this world. And that's the neat thing about 3D printing. You know, it brings the ability to create things in the personal space of your home that normally would have to be done in a very expensive place of work. And so it kind of brings that home to us, to consumers, and it's really neat. And I am going to be upset if 3D printing does not move up to another level. You know, it needs to. I want to see this within the next 10 years being in the home of every person. You know, everybody using them and doing it, and even furthermore, not only doing with plastic, but also metal. So this is an FDM printer, but they have laser centering. It's kind of like welding, and that just same thing, slices parts and lasers with light, builds up material. And then also they have resin printers that dip down in a vat. Some are LCD. I had an LCD one, and it just flickers the image and hardens the resin to create layers on top of each other and eventually build a part like this. The resolution or surface finish of those parts are incredibly different than this. FDM printer is capable of producing The resin printers can print almost like glass, depending on your settings. And typical FDM printers, they can, if adjusted and fine-tuned, can print very well and very smooth, nearly flawless, but it will be a little bit more porous than a resin printer. They're able to take it down to, like, I think 25 microns. I may be wrong. And this one's significantly higher. I think these are like 100. Don't hold me to that. But this printer, what I like about it is it's very easy to level. Look at these leveling knobs. See that? There's 3 of them. A 3-legged stool doesn't wobble, right? Pretty nice. And look at the thickness. I love that. I also have an Annette 8 3D printer. It was actually my first 3D printer that I've went back to several times because it's just a great printer. The only reason why I bought this printer and planning on keeping it over that is because that printer has been notorious for burning houses down, and it was an open bed printer. This one is closed. I can shut the door on this. I didn't have to build it or anything, it just came stock this way. I prefer that over the open bed. And another thing is, the Z travel on this is up and down. So the bed, on the up and down on this is on the bed, I'm sorry, and the X and Y are on the extruder. On the Annette 8, the bed was the Y, and so the part was constantly going in and out, and it just caused issues sometimes. With this one, the only thing that shakes the bed is the bed itself going up and down. And if you see, it's got 4 rods that are holding it up, and plus 2 more, the all thread there, the ball screws, that are driven with the DC, the servo motors. So it's very nice, very rigid. There's 2 cooling fans in the back, and also one up on the extruder. Nice vintage one there. That can be controlled on the LCD screen. That's really nice. It has an Ethernet cord here you can plug in the front there for your internet if you don't want to go Wi-Fi. And it's pretty darn nice. It's got handles on the side, you can pick it up. This thing weighs, I believe it said 80 pounds. It's ridiculous. It's awesome. The filament I got on a rod back here. You can hold multiple filaments. I've had two filaments up here earlier. Before I started this print, I took them down and put just this one up here. But it's fed through this tube in the back and then into the extruder, as we all know. So PETG prints very similar to PLA. It's pretty simple. It's just the only other requirement. The only thing different from this and PETG that I've noticed is that it's a little bit more stringier, and also you got to run the extruder hotter. So you can see in some places, you can see where it's stringing there, and then there is some trash from the nozzle over there on the left corner there. And then you can see stringing, and then there's a little bit of yellow markings. And I think that may be some impurities in the plastics, maybe some oil seeping out or something, I don't know. But there's some chamfers on the side of the part that were modeled into and it's kind of hard to see, but they are made into it very nicely. It looks good in person. At the end of the video, I will take the part out, handle it, and let you see it up close. I'll probably wipe it down too, get all the little hairs off of it. Alright, the print just finished, the flag post. Up here you can see that it says printing done, elapsed 25 hours and 49 minutes. That was the longest print I've ever done. So I'm going to hit OK. We're going to open the door and we're going to pull it out. I'll show you what entails that. So right off the bat, I've noticed we can see the details. So the first thing I like to do is just kind of look at it, see what happened, you know, for future reference. You know, I see there's a lot of stringing, so maybe it got a little hot. So maybe that's something I can do. I can turn down the heat a little bit, or maybe turn on the fans, the cooling fans. I had no cooling fans on, and so that's for future reference. This is always there. That's the last bit of ooze that comes out of the nozzle. That was the last part of the print right there up on top. But what I'm going to do now is just remove it from the build plate. Pull this out. I love this thing. It's just a removable build plate, and it just sticks on there. So earlier I was talking about some geometry that would be difficult for normal CNC machines to achieve due to the tool geometry. This is what I was talking about, some of the geometry inside this part. You know, there's no radius, there's no chamfer or anything that a tool can get in and cut this out and not create here. So with 3D printing, I was able to print those walls together. That traditional machining, it would be a challenge. I'm gonna go ahead and remove it. So normally what I do is I just bend it and it pops loose, just like so. Once I hear it, I don't hear it cracking no more, I just go ahead and pop it off. Okay, and what I like to do now is I just put the build plate back in, and well, normally I'll scrape it off, but I'll do that later. I just want to talk about this right now. We can bring the camera in here and we can really look at the details right off the bat, you know, right out of the printer. Let me see. Okay. So there's a little stringing, which this just wiped right off. I can take a little sandpaper or just my fingers, and that just brushes right off. So we got here, we have chamfers inside the part. Let's see. So if you look at the part here, it's kind of hard to see. There's some chamfers in the bolt hole there. Let's see, they are really nicely formed. Very nicely formed. We have a hole here on the side. And we have this geometry here, this little knuckle, or rib for strength, good strength. And then we have some bolt patterns down here in the bottom. Overall, a very nice part, very well done. Like all this hair, it just comes right out. So I'm gonna get it cleaned up and come back and take another video and show you what it looks like with just minimum cleaning. So I'm back. I took it out in the garage and just brushed it off with a little wire brush. Got it a little dirty inside, you can see. Obviously, that mark is still there. I took a little sandpaper and just kind of got all the little stringies off of it. So now you can kind of see the corners. See the corners how it's printed? That would be difficult to do even with today's modern machining technologies, those CNC mills don't really have tooling to get in and produce that kind of geometry in these conditions here. But with 3D printing, you know, we are able to do such things, and it's really neat. So this part right here is a one of a kind. This was designed and modeled by a good friend of mine, very good CAD modeling and CNC programmer, a very sharp guy, really look up to him, Aaron. And he designed this part and for use at his home to hold a flag. And he was having difficulty keeping flags mounted because the mounts kept busting. So he designed this from his own mind, and here it is, the first of its kind. It's now entered this world. And that's the joyous thing about 3D printing and modeling. We're able to bring things into our own lives instead of going somewhere and purchasing something off of a shelf from somebody else's mind. This is the ingenuity of this man's mind, and it's brilliant. It's got a little set screw on the side here. It looks as if the post goes in there, and you can mount it there. And that goes up on the corner of the house there. And they were bolted down very securely. So I think that he did a very good job, and that this part's going to last him for quite a while. Very, very good design, very sturdy, strong. And I'm thankful for this printer. It's did a very good job here in the Etch Max. And the first time ever printing with this filament, PETG. It's I've read that it was similar to POA, but to me there's quite a bit of difference in the feel, in the way the extruder has to be a lot hotter, and build plate also, and the way that it forms. So I had some pieces here I was experimenting with. I printed in cubic. I was gonna first try printing this part kind of hollow, and I went back and decided I want it solid for different reasons. But this part it kind of reminds me of a cracker. It's real hard, but with enough force, it just kind of explodes, just kind of breaks. It's very interesting. And POA is not like that. POA is softer. Like when it bends over and snaps, it just kind of breaks. This material pops. It's got just a crack to it, and it's very interesting. This is more like a nylonish, I believe, material, kind of stronger, up there with ABS. Except this filament doesn't really have a smell. ABS is strong. I don't like printing with it. It's super, super strong material. I have prints from a while back, years ago, and they're just, I'm amazed still today when I go back and every once in a while I'll pull the box out and look at them, and they're just so strong and rigid. Strong and held their color, they've held their integrity, and I'm just really amazed at it. And those were done on other printers, and so I'm really satisfied with this one. And I plan on printing in ABS. I just don't like to because it's so smelly. But this PETG is supposed to be just as rigid, or nearly as rigid, and temperature resistant to the heat. POA, you get a little warm and it starts getting real mushy. ABS is just solid, so it's good for outdoor things, like say for instance this could have been printed out of ABS. It would have been wonderful, but I went with PETG because it's just a newer filament to me that I've been introduced to, and it does not have any smell. I was very happy about that. There was no smell, and if there was, it was minimum. I certainly didn't smell it, and I have a good sense of smell. But turned out very well. I bought the filament from a company called Kodak. They produce 3D printing filament. It came in like that. The bottom was damaged, but the filament was perfect. Nothing wrong with it. It's very good stuff. Polymer. So, come in like a NASA space zip bag. There's it. It's pretty neat. Aluminum. Pretty cool. I got another filament in there right now. I think I got ABS. I got lots of filaments. But yeah, this is a 24-hour print. It's done. One of my first few prints that have come off this printer. My mind has changed about 3D printing in a lot of ways. Primarily in the way that, like I said earlier, about, people don't think, they see this and say, oh, it took 24 hours to print. Well, it took 24 hours to print, but it only took me a few minutes to walk over here and press a button and then come back 2 days later to this. There was no thought put into it. I didn't have to figure out how I was going to hold it in a machine. I didn't have to go and buy a machine. Those machines, CNC machines, $250,000 for a lower end one. And you know, I don't have that kind of money, but this is only a little over $1,000. And look at the capabilities of it. I'm able to produce this. And if need be that I needed it out of aluminum, then I have a CNC router also outside in the garage, and it's capable of machining, you know, metals. So, but for this purpose, we were able to manufacture it out of a plastic, and it's going to serve its purpose very well. But if you guys have any questions or have anything to say about it, concerns, just hit me up in the comments and tell me what you think about it.